Hey there, friends. My name's Matthew. I'm the C# artisan, and this is the 11th, that's right, 11th video in my series on threads. And this one is called ThreadStatic and Other Evils. Now, C# has a couple of classes and attributes. One is called ThreadStatic. Another one is AsyncLocal. And these things, while not exactly evil, they are tricky to use, and they sometimes don't quite work as expected. So in this video, I want to talk about what problem these things are trying to solve, what their supposed purpose is, what the drawbacks are to using them, and maybe what a better alternative is. So to begin, I want to introduce a term. I want to talk about what I call ambient variables. Now, I want to note that this is not a technical term you maybe will see out there in the literature. This is a Matthew term. So what do I mean by ambient variables? So these are variables in the code that are just kind of out there. They're accessible to them, and your code can just kind of pick them out of the air instead of having it pass to your functions. So an example might be something like this. String my app name equals appdomain.currentDomain.friendlyname. So the ambient variable in this case is appdomain with its property currentDomain. So where does that come from, right? It's just kind of sitting out there for you to use if you want to. It's always there in every C#.NET project you've ever written. What about this? Like, we used this when we did our little thread monitor. Threads equals process.getCurrentProcess. So what about this process thing? It's just kind of there, and you can just reach out and use it. Here's another one. If you've done some ASP.NET programming and you've built, MVC controllers, maybe you've wanted to get information about kind of the call context and the current user. So you could say current user is user.findFirstValue, and you search through the claims. And in this case, it's the user, which is kind of an ambient variable. Now, the first two are pretty simple. Those are application level. They just exist there, a single copy for the whole application. But the user is a little more complicated. And if you are in your code and you hover over, here's the tooltip, and it gets the claims principal associated with the executing action. So if this is in an ASP.NET controller method, this is different for each instance of that method. So every HTTP request that's coming in gets a different user context. So it's not just one per app. So how are these kinds of things implemented? For the ones that are truly global, the most common way is just to use a static variable. Now, the word static, the keyword static in C# is sometimes misunderstood. It doesn't mean unchanging. What it means is you have one copy per application, or another way to say that is it's an application level singleton. It can definitely change unless you mark it as read-only, but it's one per application. So let's imagine that we have a class here, and I'm calling it shared data. And to keep it simple, it just has this one static Boolean called SumFlag. So the idea here is this flag, true or false, there's one copy of it for your application. And so then if you spin up an instance of, say, a worker class, I'm calling it useful worker, and inside of it, it needs to check that flag, like if shared data.SumFlag is true, then do something. It's basically referring to your static variable. It's pointing to that. And if you spin up another worker, it's also pointing to the same thing. They're sharing it. There's one flag for the whole application. And regardless of how many workers you have going simultaneously on different threads, they are all pointing back to some flag. So for things that are truly scoped at the application level, where you really just want one per application, static works just fine. You might need to make it thread safe, but it's the way to go. But that's not really what people want a lot of the time. What people want is one copy of this kind of shared data per worker. They would like to create some ambient data that all of your workers can get access to just by kind of getting them and have their own copy of it. So how do we do that? That's what I'm going to look at in this video. We're going to write some code and we're going to talk about, how and whether to create ambient data that is on a per worker basis. So here we are in Visual Studio, and I've set up our test harness. It's called the ambient data test, and the entry method is test static variable. This should look familiar. We are starting 3 threads staggered by a quarter second. I've also got this ambient data class defined, and right now it's got this one static integer called current int. So what we need to do is implement our thread proc to do something fun with current int. So let me just copy and paste some code in. So here's what's going on. First, the thread is setting ambient data.currentInt to a random number between 1 and 99. Then it loops 3 times, and on each loop it logs out a bit of information. It logs out its worker ID, which should be 1, 2, or 3, depending on which thread we're on. It logs out the loop ID, depending on which loop we're in, and it logs out what it thinks is the ambient data. Well, what is the ambient data? And then it just waits a second. Okay, so that's all there is to that. Let's run it and see what happens. We'll press our enter to start. And you can see on thread 11, worker 1 started, and it randomized ambient data to 71. Then a quarter second later, worker 2 started on thread 12, and it randomized ambient data to 52, overwriting 71. And then worker 3 started on thread 13, and it initialized ambient data to 42, and that overwrote these other values, and nothing else ever touches ambient data. While it's inside the loops, it just keeps printing it out, and it gets set to 42, and it just stays there. So this is what we would expect if our ambient data is at the application level. But that's not what we really want. The intent here is to create worker-specific ambient data. So because of the way this is done, we can mark this static variable as ThreadStatic using the ThreadStatic attribute. So what that does is it makes it so that instead of just a single copy of current int, we have one copy per thread. So with that one change, let's rerun it, and we'll press enter. And now you can see that worker 1 on thread 11 initialized ambient data to 27, and it kept that value, right? Because worker 1 on thread 11 has its own copy, so it stays 27. Worker 2 on thread 12, it stays 92, and worker 3 on thread 13, it stays, it's assigned to 98, and it stays that way. So we have solved the problem. So now we have thread level ambient data. So it's data that's kind of out there, not being passed to the thread explicitly. It can reach out and get it, but it has its own copy. So this works great right up until the moment when you adapt all of this to use tasks, and you use async await, and then it completely breaks down. So let's implement it, and I will show you the train wreck that happens. So the first thing I'm going to do is I'm going to paste in another little launcher method. So this one, instead of test static variable, we're going to call it test async. And let's go fix the program so it calls that one. So what does test async do? Should look familiar if you watched the video on tasks versus threads. The first thing is I'm going to turn off the fancy colors. They don't work well with async code. And then we make a list of tasks. We kick off 3 tasks using this async worker, which we'll build in a second. And then we simply await for them all to complete. So what does this async worker look like? It's pretty similar to our thread proc. So in the async worker, again, the async worker is going to initialize the ambient data current int to a random number, and it's going to loop 3 times, just like our thread proc. The only difference is in the middle, instead of just doing a thread sleep, we're going to await something awaitable for around a second or two. And we are going to log our information before and after the await. So we're going to log some data, we're going to await something, and we're going to log some more data. And what we're logging, again, is the loop number, the worker number, and the ambient data value. So it looks pretty similar, right? This looks like we've mostly just ported our thread proc into an async worker. Looks almost the same. Well, watch what happens. So I'm going to kick off this test, and it takes a second to get through it because there's a little more going on. And I think it's done. So here on thread 1, worker 1 starts, and it initializes, okay, they're finishing out, thank you. It initializes the ambient variable to 43. Notice that worker 2 also starts on thread 1. So this is the key here. When you're using tasks, you no longer control which thread anything gets scheduled on. So the worker 2 and worker 3, they all started on thread 1. And so they have tried to set values for this ambient value, but they're overwriting themselves because it's all, this number here is local to thread 1. Then it just so happens that worker 2 exits the first loop, and it exits on thread 5. So after an await, when your code starts executing again, after the continuation, it's going to come back on a different thread. And on this thread, ambient is now 0 because nothing has touched it. And worker 2 starts loop 2 on thread 5. Ambient is 0. And then worker 3 ends loop 1 on thread 15, which is 0. And then as you can see, the work is being scheduled on all these different threads. And there's no strict correlation between the worker number and the thread, and whether you're at the beginning of the method or the end of the method. What's happened here is thread 1 is out of the picture, and this value is 0. So our simple code of making something thread static absolutely does not work in this scenario. We no longer have worker specific data. And that's again because with tasks, you don't have a one-to-one correspondence between the worker and the thread. So this is a bit of a nightmare. So that's the evil I want to warn you about, that if you have used thread static and you switch over to async, your code will be badly broken. So what can you do about this? So I'm going to copy something in here, and I'm going to create another static variable, a second one. And this is of the type AsyncLocal. It's a generic type, a generic class called AsyncLocal with an int. And I'm just going to call this current int 2 to distinguish it from current int. And because it's a class, we have to initialize it. Now, if we go into our async worker and we change this, and instead of saying current int, we use current int 2 dot value, and let's switch this to current int 2 dot value and current int 2 dot value. So now we are no longer using a thread static. We're using a regular static, but it's defined as this special magic async local. So let's run this, see what it does, and then talk about it a little bit. So we will start our test. Now, same as before, you'll notice that the threads are all over the place. Worker 1 is sometimes on thread 1, worker 1 is sometimes on thread 15, worker 1 is sometimes on thread 5. That's what we expect. But you'll notice now that the ambient value for worker 1, which gets set to 81, it follows it. So here's worker 1, 81. Worker 1, 81. Worker 1, 81. And for worker 2, it gets set to 42, and that sticks. Worker 2, 42, all the way down, and worker 3's value was 21. So if your code is using tasks and it's using async await, you have to use this AsyncLocal construct in order to have static ambient data that follows your worker rather through the multiple async calls, and it doesn't matter how many nested calls there are, it will follow it. So this is kind of magic. I mean, it's clearly doing a lot of work behind the scenes of matching some sort of async call context to this guy so that when your continuation finishes, it injects the right copy of this. So it does work, and I have never seen it do the wrong thing, but I want to point out something really simple here and kind of point out the alternative to all of this jazz. Did you notice that when we launched both our async methods, okay, and our thread proc, we passed in some data. In this case, we passed in the worker ID as an int, and here it's a worker ID as an object. So the reality is, it is easy to pass context data to one of your workers. You just pass it in when you start it. And then if it's calling another worker, it just has to pass it along. So the much simpler, and in my view, safer way to do this, and I think there are other people who agree, is do not attempt to use ambient data when you're multi-threading. Instead, create a context class which has whatever data your workers and their sub-workers are going to need, and just pass it down through the call stack explicitly. It is clear, it is self-documenting, there's no .NET magic happening here. You're just passing your data to the thing that needs it to do its work. So that's my recommendation. You now know what ThreadStatic is, you know what AsyncLocal is, you know enough to try to avoid them, and you know what the good alternative is. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.